limit as x goes to -1 of the sine of x squared minus 1 over x plus 1. The first thing we're going to do is try plugging -1 in for the x's. That'll give us the sine of -1 squared minus 1 divided by -1 plus 1, which is the sine of -1 squared is +1 minus 1 over -1 plus 1. 1 minus 1 is a 0, so we have the sine of 0, -1 plus 1 is a 0, and the sine of 0 is a 0, so we have the 0 over 0 indeterminate form. Since this is occurring due to trig functions together with power functions, we're going to make use of the identity. Limit as theta goes to 0 of the sine of theta divided by theta equals to 1. So what we need to do here is isolate the sine expression. It's in the numerator, away from any other remaining terms which are just in the denominator, so that we can phase match the sign. The phase of the sign in the numerator is x squared minus 1. I'm going to need an x squared minus 1 in its denominator to phase match it for the identity. To compensate, I'm going to put an x squared minus 1 in the numerator of the other fraction. After having phase matched it, I will then have a limit of 1 for that first fraction. That second fraction itself is also 0 over 0. However, those are power functions and therefore can be put through the factor and cancel method, and that's the next thing I'm going to do, because until we remove the 0 over 0, we can't actually evaluate the limit. So this first fraction, we're going to leave it as is, since it's just going to equal to 1 in its limit. The second fraction, we have a difference of squares, which is x plus 1 times x minus 1 divided by the x plus 1. And the x plus 1s can cancel, which is what was making 0 over 0 as x went to -1. And now that I've canceled that out, I should no longer have the 0 over 0 indeterminate form for that second fraction. And this first fraction, because of the identity, even though it is the 0 over 0 indeterminate form, will come out to a 1. So at this point, we should be able to evaluate the limit. We know because of the identity that's a 1, and we can plug a -1 in for any remaining x's, and we'll have 1 times -1 minus 1. -1 minus 1 is -2. 1 times -2 is a -2.